So good afternoon, ladies and gentlemen. Welcome to our session. So just I want to ask the co-organizers, can you see my blank screen? Do I share it now?
Yep.
Okay. So then if I want to start here with short presentation. So now you can see the title slide, Circular Aviation for Green Growth. Okay. So now we are quite sizable group for this event. So thank you for your interest and for joining this event. Yeah, there are still people in the waiting room and coming in. So thank you very much for interest. And yeah, I welcome you to the EU Green Week partner event, Circular Aviation for Green Growth, which is hosted by the SUSTAINAir project. The SUSTAINAir project, yeah, so my name is Jürgen, I'm the coordinator of the project, and I will be, yes, your moderator for at least the first session. Actually, to me and my job, so I'm a research engineer at the Light Metals Technologies, Ranshofen. This is a subsidiary of the Austrian Institute of Technology. And yeah, this is Austria's largest non-university research institute. And yeah, of course, so we are the coordinator of the project. And just let us have a brief look to the agenda. But first of all, I really have to say many thanks to Michaela from RTDS. RTDS is a project partner in SUSTAINAir, and also to Stein Janssens from the KU Leuven for their really professional and ongoing support in organizing this event, and yeah, for the support during today's event. So let's have a short look on the agenda. So as you can see, we start here with a short welcome from my side. Then we will have two sessions. Session number one will be a panel discussion. During the panel discussion, we have several attendees from several organizations. I will have a look, or I will introduce them later on, but we have one from Herea, from Sampe, from Airbus, from Eco-Design of the Clean Sky, and from company Jet Maintenance Solutions. So here we have all the logos of these companies and of the organizations. So thank you from my side for your interest and for attending this panel discussion. And I hope we will have an interesting discussion during the next almost 1 hour or 45 minutes. Yes, so then the second part, or the second session of today's event, will be a showcase project. So there will be Stein, the moderator of the sessions. We'll have a short welcome from our project officer. Then we will have some presentations of the project and so on. But this will in detail, Stein talk to you later, and then hopefully at 5 o'clock we will have at latest closing of today's event. Yes, so first, yeah, if you would like to ask a question, please use the chat button we have here in the Zoom. Stein will collect your questions and forward it to me. Yeah, then some housekeeping rules for you. Just I want to announce that this event is recorded. Yeah, the official hashtag to follow the conversation on social media is hashtag Circular Aviation. The slides and the recording will be shared on the event website. And as I already announced, if you have any question during the panel discussion or during the presentations, please use the chat function in our Zoom tool. Yes, and then the questions will be forwarded to the presenters. Okay, so then actually. So, okay. So then, first of all, let's start with the partner event, with the panel discussion. Yes, so the panel discussion is on circular aviation, the past, present, and the future. And therefore, I'm very, very happy and I highly welcome the panelists of today's discussion to elaborate on, as I already mentioned, on the past, present, and the future of circular economy approaches in aviation, which is also known as circular aviation. For this, I warmly welcome our 5 panelists. So the first on my list I have is Ligia Paletti. So she is, hi Ligia, good morning, hi, good evening, yeah, so we'll talk to you later. Just a short introduction from my side. So Ligia is an aerospace engineer. She's working at the NLR's Aerospace Vehicles Division. Within the Future Sky initiative of the AREA, the Association of European Research Establishments in Aeronautics. She is the team leader for circular aviation. And of course, as I already mentioned, she is working for NLR, and NLR is also a partner and the work package leader in the SUSTAINAir project. The next panelist I would like to welcome is Irene Fernandez-Villegas. She is an associate professor at the Faculty of Aerospace Engineering, Aerospace Materials and Structures Department at the Technical University of Delft. As an expert in polymer composite welding technologies, she's representing the SAMPE, also called the Society for the Advancement of Material and Process Engineering. So highly welcome, Irene. And I also want to welcome Isabel Gredert. She is the Airbus Fast Track leader for materials and the general advisor for materials technology to the chief technical officer of Airbus. In this capacity, she leads the company's cross-divisional materials roadmap for associated technologies, for which material end-to-end sustainability plays a key role. She is an aerospace engineer based at Airbus Bremen in Germany. Hi, welcome, Isabel. So then, thank you for joining us, Sonel Schroff, the next in the panelist. She is a project officer at at the Clean Sky Joint Undertaking. She's responsible for the EcoSign related activities. She holds a PhD in aerospace engineering from the TU Delft University in the field of aerospace structures and materials. Hi, welcome, Sonel. And finally, we have on board White Tortoise Racers from Jet Maintenance Solutions, a company which is a provider of integrated world-class aircraft maintenance, repair and overhaul solutions. Hi, hello, White Tortoise. Hi. Thank you for joining us. The company is a family member of Aviation Solutions Group, the largest aerospace business group for Central and Eastern Europe, offering aviation services worldwide in their more than 100 locations. So let us start with the first round of questions. I've prepared some questions. I will ask one after another from your side. Maybe let me start with Ligeia from representing the AREA. Ligeia, in a white paper on circular aviation, which was issued by AREA in December 2019, we read that the AREA's ultimate vision is efficient, safe, and environmentally friendly aviation system in line with societal expectations. So just it was a few days ago, just their AREA presented a new vision, the AREA Vision Study, The Future of Aviation in 2050. Ligeia, please share with us what is AREA for those who don't know what AREA is and what is the relationship with the Future Sky, the research program which endorsed at least the SUSTAINAir project. And yeah, of course, Ligeia, can you tell us more about the AREA Vision Study program and so on? So I will give the word to you. Thank you very much.
Thank you. Thank you, Jürgen. Thank you for having me here. And well, a very long list of good questions. So let's see if I can give some clarity on the overall concepts you mentioned. So yes, today I'm here representing AREA, Future Sky, and the circular aviation theme. I know my colleague Stefan Ravin is also online. He is also part of the core team. And so to start, what is AREA? AREA is, it doesn't seem like I can, okay, sorry. So what is AREA? AREA is the association of all European research establishments active in aeronautics. So it's covering 14 organizations, 14 countries, and within AREA, what we do a lot of high-level talking. We try to position aeronautics research in the places in Europe where the research needs to be done, where the research can contribute. So there's a direction in which we identify what research is needed in aeronautics, and on the other hand, we try to make sure that that research gets done. Within AREA, so very high level talking, one level down is the Future Sky initiative. The Future Sky initiative was created to address specific topics that are necessary for the future of aviation. Those are 6 themes, and one of them is circular aviation. And this theme came into being in 2018, beginning 2018, when simply words about circular economy started to be pronounced around more loudly than in the past. And well, some people in the research establishment started to think like, okay, is that something for us as aviation industry, as aviation sector? Do we need to do anything about it? So that thing ended up on my desk, and Stefan, who's here today as well. And we basically engaged colleagues from across Europe in, okay, what is the concept? What is circular economy? Because I didn't know anything about it. What's in it for aviation? And we wrote the white paper you mentioned. We generated like a roadmap, and we set up some goals. Of course, goals are always good to know where we want to go. And the goal of the Future Sky Circular Aviation Group is to enable a first fully circular flight by 2050. And we said flight because it's not just about the aircraft, it's not just about the emissions, it's not about propulsion only, it's about operations, it's about the airport. The circular economy is about a loop. And well, to have a flight, well, you need all players to achieve that. Given the background of the specific group, we have other goals really oriented towards the aircraft manufacturing, aircraft production, materials used. And we did not reinvent the wheel. We tried to look around on, okay, circular economy is already establishing targets in other industries. So we sort of learned from that, and we kind of mirror targets that are already present in other EU directives. I mean, those are just our targets. It's not like any kind of European directive or any law by now. We aim at that, but this is our goal. So our goal is we really want to have aircraft that are really recyclable, really reusable, and the minimum part of it is ending up in a landfill. So this said, is like we have a roadmap and we have all this kind of nice talking, and that's not enough. So within this Future Sky Circular Aviation group, the SUSTAINAir project also got developed. The concept of it, of course, started as a conversation in that group that then resulted in the project. So we are talking a lot. That's what all those European groups do sometimes. It sounds like we just talk, but we don't only talk. We're also trying to do something, and today we're going to show us about SUSTAINAir. But now you also asked about the vision study. So it's kind of a coincidence. There's my face on both initiatives, but they're not the same. So in parallel with AREA normal daily activities, AREA decided that they felt the need for a vision, so some direction to go towards the future. So last year, we initiated this exercise that involved about 100 AREA experts from across Europe. And the result was presented last week. But they're not the same. So as I said, those are really two different things. The vision study, the future of aviation, gives scenarios on how the future of aviation could be. And in some scenarios, there's no circularity, there's no sustainability, there is no circular aviation, there's nothing of that. So that's important because, of course, from my perspective, I want circular aviation to happen, but that's not a given. And for me, that motivates me in I need to position the research establishments, I need to position research topics in a way that all the steps that we are making go towards a scenario where aviation is circular. But the two exercises are separated, so it might be confusing, but circular aviation is a small part of the vision of the future of aviation of AREA. And yeah, so what we do, we know in the group that we really want to achieve this fully circular flight by 2050. And what we want to do with the group is to close the loop. We do know a few things about aviation in the group. We do have some knowledge of the aviation industry. We know a few people here and there. And what we want to do in the Future Sky Circular Aviation Group is helping the industry to close the loop. Try to show others how the partners are connected to each other, like the links that can be made in the chain. And then when the loop cannot be closed, well, that's where research is needed. And that's where the research establishments together with universities could help. I hope I answered your question, Jürgen.
Thank you very much, Licia. Thank you very much for your clear answer, and then thank you very much for that, for your contribution. So I want to proceed with the next panelist. So Irene from SAMPE. We just heard from AREA that, let's say material innovations are important to enable the evolvement to a circular aviation. And my question is, what does SAMPE do in this field of recycled materials? Do you have an overview of the recyclability practices across other industries? And yeah, Irene, what I'm very interested is, what are the trends observable among the SAMPE members? What trends in material development and processing? And what are, of course, most important, what are the challenges there? Can you give an answer to these questions?
Yes, of course.
Thank you.
Yeah, thank you very much, Jürgen, for your questions, and thank you very much for inviting me to be here. It's an honor. and a pleasure to be here. So I'll try to answer your long question. Well, first of all, so in case not everybody in the audience knows what SAMPI is. So SAMPI is actually a global professional network for the advancement of materials and process engineering. So it's a mouthful, basically to translate that, professional network composed of engineers, of academics, of researchers, all together trying to advance these two very important fields. What actually do we do for our members? We basically enable the exchange of technical information among all the members. So we identify needs from all different levels in our organization, and we try to make sure to bring the knowledge and the education to our members in those topics that they feel the need to know more about. And of course, one very important one is sustainable materials and processes. So we've been hearing more and more from our members, from society, that this is a need. And our involvement in education, in enabling information, exchange of information on these topics has been growing. So just to give you an example, well, of course, we organize, in order to exchange this information, we organize meetings, technical meetings, exhibitions, conferences. And as an example, in 2021, we organized the SAMPI Summit in Paris at the end of May. There's the SAMPI originally Baden-Zurich European conference, although it's going to become a virtual conference in September. In all of them, and also in previous conferences, we emphasize this topic, sustainable materials and processes, in our calls for papers. We also organize thematic sessions around these topics. For instance, in the SAMPI Europe conference to be held in September, there's going to be 2 thematic sessions on projects that are directly linked to sustainable composites in aviation. And on top of that, we arrange keynote lectures and we invite speakers to talk about these topics. So that's what we do for our members. Yeah. So what is the, you asked, to give an overview of what's out there. So actually, what is quite interesting is that I don't think we tend to realize about this, but if you look at aviation, you could say that it's already very circular. And perhaps Ligia would disagree with me here. But if you look at current end of life of an aircraft, so if you follow the right guidelines, you could actually be able to reuse or recycle up to 85 or 90% of the aircraft. And what remains to be recycled actually is quite funny. So it's composites, polymer composites and interior materials. Of course, and then we can already imagine that this number, the number of materials that go to the landfill, is going to increase if you don't do anything about it when aircrafts like the A350 or 787 get to their end of their lives, because they have much more composite materials than current aircraft being decommissioned. Of course, this actually is quite interesting, also happens in other industries, like the wind energy industry. Again, 85 to 90% of the wind turbines are recycled. But what is recyclable there? What is reusable there? What is the foundation, the tower, the gear casing, the generator? And what is not recyclable? Well, the composite wind turbine blades, right? So we come back to the same problems across the industry. And what are the trends that we are observing? As I said before, in the last decades, we've been sensing an increased interest in circularity, and of course, the different topics and aspects related to circularity at different levels within the SAMPI community. Especially In the last years, we've observed a strong and growing interest in thermoplastic composites and in short fiber production processes related to the processing of recycled thermoplastic composites. Also, there's a strong interest in LCA, as a life cycle assessment, as a design tool. And we also see a lot of interest and a lot of papers submitted to our conferences on biomaterials, biofibers, also reversible cross-linking for thermoset composites to make them more recyclable. So this, if I had to summarize, these are the trends that we are observing. And what are the challenges? If I remember properly, that was your last question. Okay, so I would like to put it a little bit more, what's the way forward, and a little bit more positive. Of course, research and development. So I think the community already knows that there's a lot of recycling options for carbon fibers, for composites out there, but they need to be industrialized. So more development is needed there. Also, not only for composites, but for all the new materials incorporated in aircraft. So there needs to be research and development on these recycling technologies, also on recyclable materials, also on looking at things from a more holistic point of view, like the life cycle eco-design of an aircraft, but also on when we manufacture an aircraft, taking into account the end of the life. So, for instance, traceability of materials used, labeling of materials used. So all that holistic approach needs to be incorporated in our research. Very important as well, and not so technical probably, but policy. And especially we're thinking of the aircraft end of life. As I said before, if we adhere to best practices, so then we can recycle a lot already. But there's no rule, there's no regulation that is forcing companies to do that. And especially disassembling aircraft, the commissioning of aircraft, when you do that, you have to deal with hazardous materials, which can pose a threat for the environment. So all that needs to be regulated. And last but not least, business models. I think I've heard many times, yeah, we can recycle things, we can recycle a lot, but it is not cheap and it doesn't make sense financially. So I think there needs to be applications for all these recycled materials, especially I'm thinking of composites. Applications for these recycled composites need to be sought. I think we need to be ambitious, and instead of thinking of downcycling, we need to think of upcycling the materials. And also there needs to be a consistent supply chain for offer and demand of these recycled materials. So I think this, hope I answered your question and I didn't skip.
Quite perfect. Thank you very much for this, for this extended answer, and to give us some insight in SUSTAINAir first, explain what SUSTAINAir is, and also to tell us about the trends you observed, and of course the trends in material development and processing was very interested, just for the whole audience to get a little bit in contact with these organizations, to know what they are doing, and so on. Thank you very much for your contribution. Thank you. So switching to the next, I want to switch to Airbus, to Isabel from Airbus. So Isabel, we just heard that there is a lot happening and a lot of research work is done on the development of new recycling methods and routes and applications on the aircraft, materials and processes, enabling advanced aircraft concepts in the future are continuously developing with a focus on sustainability, on functional integration and digitalization. And there's my main question: what trends do you at Airbus observe? And Isabel, where does Airbus see applications in such circular materials on the aircraft? Please, can you answer this question.
For sure. Many thanks for this kind introduction and for all these questions. So I will try to focus really on the sustainability aspect here. So as a global company, operating in a fast changing market and as well with a societal environment, we see it really as our duty to transform the business, to transform the way how we conduct business, and as well to make our product in the whole life cycle and its operation more sustainable. Airbus has identified materials as a fast-track technology. It means that we see it as a strategic and competitive technology, which hold promise to overcome future challenges in our company, but as well in industry at large. So I'm leading this material fast-track, supported by the overall material research and engineering community. Let's have a look where we are today. So in the aviation industry, some ways of working are already in line with some of the main principles of circular economy, and here I would like to mention some of them. So the limited usage of resources and raw materials is leading to weight reduction. It's a key factor of operational performance and competitiveness, but of course as well for fuel reduction. Our products have already a relatively large or long life cycle with up to 30 years, which can even be extended by passenger to freighter conversion. Maintenance and repairs are instrumental to our business model with no planned obsolescence and as well a well-developed secondary spare part market. High 5 Plus is the name of our company-wide initiative for supporting the reduction of the environmental footprint on air, soil and water quality, climate change, resource availability, but as well on waste reduction and recyclability. And finally, Airbus has pioneered the aircraft end of life at highest environmental, health and safety practices, which was leading to the Tarmac joint venture creation in 2009 already. So we can achieve up to 92% of today to be recycled aircrafts according to weight recovery rate for the commercial part. Now at Airbus we lead the decarbonization of the aviation industry, and therefore we aim to develop the first zero emission aircraft market by around 2035 in order to make sure that the next generation can enjoy flying as much as we do it today. In order to evolve on circular economy principles, we focus for materials on three main aspects. So first of all, the material inflow. So what kind of materials are we using to produce our aircraft? Here we want to we aim for using materials with an increased recycled content or bio-based content. We see good opportunities to establish for some specific metal alloys a closed loop in the future, but as well we want to move away from the total reliance of the petrochemical industry for composite or carbon fiber production by using biomass. Material reuse is another very important element. So we try already to minimize the waste which is created during the production, but there is some unavoidable waste. This one we want to reintroduce back into the production. And here one good example might be that we are using or we're working on using composite manufacturing waste for reintroduction as interior material, for example, for the cabin linings. The material outflow, we have said several times, is of course something very, very important, and we want to continue to increase the percentage of recycled and reused materials. And here I think it's very important really to have this kind of design for dismantling or design for recyclability criteria. It will be a key enabler really to go for to reduce the material mix, but as well to have less efforts on the segregation of materials at the end of life. We are working as well on upcycling concepts. You might have heard already about the piece of sky, where we transform material parts into furnitures. Or quite recently, we have communicated as well about using carbon composite waste to produce bicycles. On top, it will be very important to work on enablers for business integration. So to be concrete here, it's about really having criteria for decision making during the design of a product, but as well maximizing on best practices, linking it to all the eco-design initiatives, and of course working on some specific technologies. Now, to bring about more sustainable aviation, we would need to really have a coordinated efforts within the aerospace ecosystem and beyond. And I would like to highlight these three elements. So first of all, we need to engage with the full supply chain, because around 80% of the structures is part of the supply chain. We need to collaborate across industries. That's very important, because if we can't go for closed loops within our industry, it's important that we go for open loops in order to bring with aerospace materials, let's say, value in other industries, in order to have an overall support the overall objective of the increase of circularity worldwide. We always need to have in mind that in the aerospace sector, we have one of the highest requirements on materials, but one of the lowest volumes. That's important to know. And last but not least, we see a great opportunity for synergies effects, let's say, underlined by the institutional support from the national and European level. Here it includes about sharing on best practices for aircraft end of life, but as well harnessing on the EU strategy for digitalization to effectively support the data transparency and traceability for the entire aerospace ecosystem and beyond. Thanks.
Thank you very much, Isabel. Thank you very much. I really like your presentation. So the way that we need a coordinated way to enable the circular economy, I really like it. And thanks, really, thank you very much to talk about the next generation aircraft. The next aircraft is a net zero Airbus platform. It was quite impressive what's going on in this business, and thank you for sharing your knowledge with us and for telling us about this thing. So thank you very much for your contribution. Thank you.
My pleasure.
Thank you. So the next panelist we have here from Clean Sky, Sonel, I have here. So hello, Sonel. Hi, Sonel Schrock.
Hello, everyone.
So circular aviation is responding to the societal demand for sustainable aviation. Its economical and sustainable approach throughout all aspects of aviation is completing the search for carbon neutral solutions to novel propulsion systems, especially when we take into account that raw materials handling and processing takes typically about roughly 40% of greenhouse gas emissions worldwide. So the Clean Sky joint undertaking tackles this with a dedicated development stream, the so-called eco-design. So Sonel, could you tell us more about eco-design, and could you give examples of successful eco-design practices or applications? Can you share some of your knowledge?
Yes, of course. I will try my best. I'm really happy to be here. I'm joined by some very, very interesting colleagues. And I'm so glad to share this enthusiasm and the passion also for circular aviation. As a project officer at Clean Sky, and especially working with eco-design, I have to say that eco-design is in our DNA. If I can just give you a small picture of our program, how it's structured at this time, you will see on the presentation that I'm sharing with you, that we have a number of platforms that we are developing in the form of demonstrators, but we look at within Clean Sky at the entire life cycle of the aircraft. So we are not just developing platforms with innovative technologies, but we also pay a lot of attention and put immense focus on understanding what is the impact of each of these platforms as it would be to reach the goals of zero net emission aircraft in the future. So starting with just with innovative technologies and putting it on an aircraft, we make sure that within our transfers activities, for example, in technology evaluator, we study what is the operational phase burden of these aircraft. What is the CO2 emission? How much is the reduction? Also for NOx and so on. But like we are discussing now, it's not just the operational phase, but we are focusing on recycling and such issues, which makes it very clear that no matter how much we want to resist, staying away from these policies, they are coming in the future, and we should be prepared for it, is to make sure that we take into account eco-design principles also when we start designing an aircraft. And that has been the main focus of Clean Sky. I want to give you a bit of history of the eco-design principles as it came about in Clean Sky. It was initiated over a decade ago with Clean Sky 1. And the basic concepts that was important within Clean Sky was to understand that the shift of this burden of having end of life and to recycle should not only be at the end of life, but it should be distributed equally among all the life cycle phases of an aircraft. So we cannot wait till the aircraft has served its 20-30 years, but we should start much before to ensure that we are using the right principles to design it, so that we don't roll out a product into the market which we cannot guarantee will not be sustainable to a certain level. And in order to do that, we need a lot of data. And that is something that I'm sure all my colleagues sitting here today with me in the panel, also in the audience, will share my grief with, is that we don't have enough aviation-specific data for all the processes that we use. Of course, there's a matter of confidentiality, but there's also a matter of logging the data. And at this time, I'm very happy to say that the initiative that was started in Clean Sky to build a common aviation-specific database so that we can carry out LCA and to have access to these complex LCA models across our various industry members and partners has been very appreciated. And within Clean Sky 2, which is the follow-up of Clean Sky 1, we are continuing to do so, and quite satisfactorily, I have to say. What is very important to state is that with Clean Sky 1, we always had the intention that the awareness to include the LCA within the early phases of the design was very, very key to the success of making eco-design a part of the DNA of every industry, of every partner that we work with. Now, I don't want to amount too much in history, but in 2011 we had this slide which was presented by my predecessor at a conference in Lille, and it was already ensured that we would be looking into a green design, green manufacturing, maintenance, and the disposal of a product life cycle. And all these principles were put together into something called eco-design for aircraft at that time. Now, cut to the end of Clean Sky 1, we already had a list of demonstrator locations which were identified along with our partners, Fraunhofer, who will be presenting in the second session to all of you. So I don't want to, spoil any surprises. So no spoiler alerts here, but we had a number of demonstrators which were identified, and I share with you a very simple picture of some of them. And you would see that they come from various categories, and it includes a lot what we have discussed before me with the other presenters on biocomposites, on certain kinds of specific alloys. We also heard some of my co-speakers talk about the hazardous substances. So these are all things that we have been looking into within Clean Sky from Clean Sky 1 onwards. And now we are also doing the same in Clean Sky 2. So what I want to say is, with all the case studies, with all the work that went into Clean Sky 1 already since 2011, we have come a long way now to say that what all of us have been talking about is part of eco-design. It's not just to look at recycling, but also to look at how I can design a product which is recyclable. So even if we want to reduce weight and we want to make an aircraft more efficient, it's important to understand that the LCI data and the LCA that we get out of the tools that we use these days should help us make the right choices in the design. So this is something that is part of every Clean Sky project. This is what we push all our partners to look into. So by default, if you're working with Clean Sky, you are focusing on green technology. There are a lot of nice keywords here for you to look at later on if you're interested. But this entire life cycle needs to be taken into account if you work on a project and you want to ensure that your product is going to be eco-design compatible. At this time in Clean Sky 2, what we are busy with right now with Fraunhofer as the partner in charge of the EcoTA is that we are collecting a lot of LCI data from our partners, whether it is from the large passenger aircraft domain or from the fast rotorcraft or from airframes. And we are carrying out an LCA analysis on several key products, some example technologies, also processes, and we hope that at the end of the Clean Sky program in 2023, we will have eco-statements on these demonstrators and technologies to share with you and to disseminate the information that it is absolutely worth considering this approach in your entire life cycle. And there are several examples of projects that we have been working on. And some of them, to name a few, would be the Copperbird, which is a ground testbed. We also have some eco-design for airframe projects, small and large. But I think I will stop here and I will leave the rest of the projects to be discussed at the next discussion with Torsten and with Rainer, my colleagues from Fraunhofer, in the next part of the program.
Yeah, thank you. Thank you very much for giving us some insights into Clean Skies, Clean Sky 2, and then eco design. So we have Torsten in the second session who will, as you already mentioned, will talk about this. And now, thank you, Sonal, for your words. Thank you very much. And now I want to switch to our last panelist, to Vaidhautas from Jet Maintenance Solutions. So Vaidhautas, the SUSTAINAir's approach is to develop strategies for prognostic type of structural health monitoring, and for repair of similar and dissimilar material combinations. So Vaidhautas, my question is, what kind of challenges are there in the MRO industry at this point in time? What you at JetMS observe in your daily work, and how does JetMS tackle regular maintenance tasks? Please, can you give us an answer to this couple of questions?
Yes, sure. Good afternoon, everyone. Thank you for having me. It's a pleasure. So before answering your questions, Jürgen, let me introduce ourselves, because JetMS is company, one of the companies of Avia Solutions Group, our big family of various aviation services. So JetMS is based in Vilnius, capital Lithuania, where we're providing base maintenance services, and also acquired RAS Completions Company in Biggin Hill, UK this year, where we provide interior services, aircraft paintings, and also established line maintenance in Nice, France. So as a one-stop shop of all services for regional and business aircrafts, we are a company of Avia Solutions Group, which has more than 100 locations globally and have companies in various areas like aircraft trade and leasing, passenger charters, cargo charters, IT solutions, ground handling services, and etc. So, talking about challenges of MRO service providers, one of the important roles, of course, is exploring new ways of aircraft utilization options, and of course, with the goal of sustainability. And minimal impacts on the environment. So, as we say, lead by example. So, I would like to share our example where just the idea came with a huge, big, and impressive project. Our company was stripping a real Bombardier CRJ aircraft and took off all valuable parts, leaving just a fuselage that is being used in one of the new offices as a decoration, inspiration, and sometimes, as I say, creativity equals to sustainability. So, this was done a couple of weeks ago here in Vilnius, and this building will be one of the Aerocity offices here in Vilnius. So let me share video, please, for you and see how it was done. Yeah, so here is the project, and I welcome you all to our Aviation Valley, which will be opened this year.
When your WordPress website fits like that, works like that, and runs as fast as that, it feels good.
Yeah, sorry for that. So, of course, teardowns and aircraft utilization is just one part, and this project was one of them. We had similar project where the aircraft also took a last ferry flight to Finland, to Aviation Engineering School, and will be as a simulator there. So that's also one of the same projects. And answering to your question, Jürgen, what kind of challenges for MROs? Of course, MRO is acquiring increasing commercial and I would say socioeconomic significance. So all those products and goods with with high investment costs and long lifespan, especially in the sectors like energy, transport, and aviation itself. So, well, considerable portion of commercial profits are generated and generated by after-sales services, so as we call aftermarket. So it's really important to switch to predictive maintenance. There is still a quest how to best predict the maintenance and plan the events, and to ensure that these maintenance processes are not just scheduled, but but the aircraft is in an optimum location, and to maximize the availability of our maintained assets. Speaking about the real world and people and parts, this is of course a technology viewpoint, and well, we are constantly asking the question to ourselves about technology utilization, which well, new technologies can be deployed now, and how best should they be used. So, well, this means that we need to take the advantage of powerful diagnostic capabilities, of all innovation capabilities, and this tremendous speed of processes that can be achieved by integrating these systems into organizations like MROs. And well, of course, they must brace themselves to deal with these powers and to make them work in their favor. And yeah, so talking about how jet maintenance solution tackle these tasks. So I would say in more maybe elaborated form, and by application and implication sustainable maintenance practices, and well, of course, of high-end quality aimed at increased technical performance with improved functionality of equipment and technical staff, using its safe, secure technologies, and reducing or eliminating downtime. So these are probably, well, the main factors and how we are dealing with them.
Okay, so thank you very much, Vaitatas, for giving us this impressive insight into your MRO business. So just before closing, thank you very much. Just before closing this session, I've seen in the chat there is a question. So maybe we can, this question can be given orally by this person, because it's from a project partner from SUSTAINAir, from Invent. Invent, as I told you, is a project partner in the SUSTAINAir project and also a work package leader. And there he has a question for you, Vaitatas, to ZMS. So Mr. Stefan Steger, he's the head of the business development of the business unit Aviation at Invent. Can you please ask your question? Maybe Stein or Michaela can unmute Stefan.
Hello, everybody. Can you hear me?
Yes, perfect.
Hi.
Okay, that's great. So far, thank you for all these presentations, and I'd like to address one topic. We've seen a lot of things when it comes for material exchange, go from aluminum fuselage to composite fuselage when it comes to overhaul of these items later on. Now we go even a step further. Aerodynamic improved surfaces on laminar flow wings, for example. We have conducted several projects on these movables with gapless surfaces, on control surfaces, on high lift devices. And always the question is, later on, you have a smooth aerodynamic surface, and now it comes to operation, which is energy efficient, less drag and everything, but still there are MRO cycles, and you have now not a screw and tolt solution and short turn cycles and AOG cycles, which is your point of view to that topic, will be maybe in the next decades a topic which is then a development in control surfaces when you have novel structural concepts to exchange, and a movable which needs to be reestablished with gapless and smooth surface. That takes time. What's your plan about some ideas in that development?
Well, we consider various capabilities, and of course, technologies are changing rapidly, and we are trying to implement all the innovations and to plan as much as efficient for every single maintenance. And talking about decreasing the drag, if I understood you correctly, so together with RAS Completions, our interior and exterior company, we are also offering some liquids like nano and some other colorings for the aircraft body to decrease fuel consumption and to increase the efficiency of aerodynamics. So we constantly are looking for all the innovations and trying to implement in our company.
I was thinking about typical damages for landing flaps, for example. You have impact, and you have then your overhaul activities, exchange of flaps, and now you have maybe a smooth surface and one continuous top and lower panel with a flexible joint, and you have material mixers. You want to look at these in SUSTAINAir for detachable joints to address that technology at a really low technology readiness level, but let's say in 2 decades, whatever, that is maybe if that structural concept will be the solution on one hand. On the other hand, energy provided by different engine and concepts and propulsion systems that will help as well. But from my point of view, structural perspective, also these elements of exchangeable items will change.
Well, I agree to that. I agree to that.
Okay, Stefan, many thanks for your interesting questions and comments, and also Bautautas for your answering the questions and also for your comments. So thank you very much. Just want to announce due to lack of time, so we are a little behind our time schedule. So unfortunately, we have to close this interesting panel discussion. And just want to announce to all participants here in attending to this partner event that all the questions from the participants we will answer in short videos, which will be published on our YouTube channel and at the event website, just for your information. And now let us switch to the second session for this. So first, before we switch, really thank you very much for all panelists, for the time, for the effort, for their very, very interesting presentations, for giving up insights into their work, into their organizations. Yeah, and for sharing with us their perspective and vision on circular aviation. And now I want to switch, thank you. And now I want to switch to the next session, which will be moderated by Stein Janssens from the KU Leuven. So Stein, the stage is yours. Thank you very much.
Yeah, thank you, Jürgen. And good afternoon also from my side, everybody. Welcome to the second session, where the aim is really to show you some key enabling technologies supporting a shift to a circular aviation. some technologies that are under development in European research programs under both the Horizon 2020 and the Clean Sky program. And for that, we have invited speakers from a selection of projects, which you can see on the slide here. Morpho, Dominio, and SUSTAINAir from Horizon 2020. And we also have an outline showcase on the eco-design developments in Clean Sky. And I'm very curious to learn more about these initiatives and how they contribute to a circular practice in the aeronautical sector. I do remind you that questions for the speakers can at all times be posted in the chat. Questions for this session will be answered in a short Q&A round after the presentation we have of those 4 showcases. Now, before we dive into the different projects, I'm more than happy to introduce you to Mr. Jürgen Felix, Project Officer at SUSTAINAir. That is the European Climate, Infrastructure and Environment Executive Agency of the European Commission. Mr. Felix has in this role the responsibility of the technical and administrative management of research and innovation programs in the field of aeronautics in Europe, and also in international cooperations with Japan and Canada. Mr. Felix, we are very delighted to have you on board at this conference, and I kindly invite you for a short welcome from your side.
Thank you, Stein. Thank you, everybody, to be present at this workshop, and thank you, Jürgen, for organizing this. I will be quite brief in my presentation because also my presentation had to be cut because I wanted to present to you the new work program Horizon Europe, but I was not allowed to present it because it will be officially presented in the final version on the 21st of June only. But I think that Michaela has already sent you the link for the draft version, and she has also collected the different topics for 2021 and 2022. There are 3 in 2021 and 3 in 2022. Normally the text will not be modified. They are still discussing with some modalities with the member state, and so still some nights to sleep and to have a new work program alive. So first, we were before INEA and we moved to a new name. It's SUSTAINAir. And why? We can go to the next slide, the second one. Yes. So since 2014, INEA has grown its CEF and Horizon 2020 portfolio. And from April of this year, we become SUSTAINAir, the Climate, Infrastructure and Environmental Executive Agency. And for 2021-2027 programs, we have added other areas such as climate, environment, and maritime. So we can go to the next slide. And so we are implementing the new portfolio of the European Green Deal, the roadmap for making the European Union economy more sustainable. And we will have a key role in supporting the European Green Deal. So we will try to boost the efficiency use of resources by moving to a clean circular economy, restore biodiversity, cut the pollution, and achieve climate neutrality by 2050. Yes, so we will be SUSTAINAir will focus on creating synergies to support a sustainable, green and decarbonized Europe, and we will become the focus point for that, for green and infrastructure project. We can go to the next slide. So in addition to the legacy program, the SUSTAINAir will manage the CEF2 transport and energy, so it's Connecting Europe facility number 2, renewable financing mechanism, a just transition mechanism, which is public sector loan facility pillar, Horizon Europe for cluster 5, innovation funds, but this has already started in June 2020, and the LIFE program. By the way, this is a very short presentation. I can provide to Michaela the full presentation with some slides with a different program that we will manage. But it was not so interesting for this workshop, and it can take too much time. You can go to the next slide. Yes. So Horizon Europe, we are adding the climate action to the existing energy and transport portfolio in Horizon Europe. And so the next generation of the European Union action will be spread over these three important thematic. So project will focus on fighting climate change and making the energy and transport sector more sustainable. We can go to the next slide. And we have an indicative budget per program. If you remember, in 2020, at the beginning of INEA, at the end of INEA, the budget managed by INEA was over 34 billion euro, and by the end of 2027, the budget that will be managed by INEA will be over 55 billion euro. And Horizon Europe will be about 10 billion euro. So we've got that budget here. The staff was in 2020 300 staff members, and we will be around 500 in 2027. Yes, so this is the end of this very small presentation. I think that Michaela has one slide with some important information with regard to expert registration.
There is no slide, but the registered participants will receive the invitation for email, but maybe you can explain a bit.
Yes.
What is it?
So every time I have the opportunity to speak to an audience, I remind the fact that we are always looking for new blood for the expertise. These projects that will be presented after my short speech have been selected by a panel of independent experts, and we are always looking for new experts in the new sector that we are managing. So register to the database, and very important, when you have your expert number, drop me an email, and so we can add your name in our database of expert in aviation. This is very important because the global database is about 100,000 people, and we are looking for experts with keywords. That we are selecting expert in aviation, and we've got our own database. This is much more efficient. And so even if you are not selected for evaluation because you can have maybe conflict of interest, I guess that people from Airbus have more conflict of interest than others for the evaluation. But nevertheless, everybody can be very a good support for us as project officer for the assessing of a project after each period, acting as an independent expert. And so this is a very useful task for us to assess properly the project with the right technical knowledge by the right expert selected by us and commonly agreed. So Michaela, please send these links to the people of participating to the workshop. Sorry, and after you have registered, drop an email to me, and we will get in touch afterwards.
Exactly, there have been some questions on that, and I also responded in the chat. So everybody should receive its email with this information.
Yes. Also, one thing: after the work program will be published officially in the final version after 21 of June. If you have any question, drop me an email, and I will contact my colleagues of DGRTD to provide you the right answer as quickly as possible.
Okay, thank you. And thank you very much, Mr. Felix, for this informative overview on how SUSTAINAir actually supports the implementation of the different EU programs, including projects specifically targeted to sustainable and a circular aviation. Now let us now take a closer look to some showcase examples of such projects, starting with Morpho. And there Mr. Nazim Iqbal will guide us through this interesting brand new project where integrated sensors and digital technology are used to benefit the life cycle management of structural components. So Mr. Iqbal is a full professor at the Lab for Process and Engineering in the Mechanics and Materials, and that is at the Conservatoire National des Arts et Métiers in Paris. And he's also responsible for the Dynamic Structure and Control group there. He has more than 18 years experience as a researcher with a well-established position on structural health monitoring and smart structures. And so it's my pleasure to give the floor to Mr. Iqbal, please.
Thank you. Thank you very much. Thank you for Michaela and for all the organizers to give the possibility to give some insight about Morpho. So Morpho project, I'll be quick. Morpho project, it's about embedded lifecycle management for smart material, but specifically to some parts of the engine. So some background. So I think that the call is very clear. It was next generation multifunctional intelligent airframe with the emphasis on manufacturing, maintenance, and recycling. So what we propose in Morpho that I will present you here, just after is to give a solution to support development of some smart aeronautical engine, specifically fan blades, that I will present you, by undoing them with some cognitive capabilities, and also optimize all the manufacturing cycle and the management of the life cycle. So the project is just started in April. So there is no new, result, but I'm going to give you just a big photo about what we were going to try to do during this 3.5 years that we can. So in Morpho, what we want to do is to design an innovative, robust, and environmentally friendly industrial process for this type of airframe parts that are multi-material structures, as I will present you. And we are going to give them some intelligence, some smartness by embedding them with some structures from the manufacturing to the recycling. So this is what we call a relay on embedded sensors. And this, in parallel, we are going to develop hybrid twins, some that I will present, that will follow all the real life cycle of these structures. Okay, so just the consortium, so 10 partners from 6 countries. From here, the coordinator, it's RMIT and SAM, CNRS. And then we have colleagues from TU Delft, Patras University, and then some end user, principally Safran. This is done typically for some airframe parts for the engine from Safran. And we have some from Hofer, one startup, which is Fisense, typically for fiber brag. And we have ASI for the parts of helping for the twin, for the digital twin part of this project. Okay, so what I was talking about, it's about this type of fan blades that is equipping the LEAP engine. It is a famous engine from Safran that is working very well this last years. And this fine blade, it's made from hybrid materials, a leading edge in titanium, and the core in 3D woven composite. And the idea is to work on this fan blade from its manufacturing to its recycling. So the concept, it's a famous circle that we saw it before in the first session of this afternoon. So we go from the design, manufacturing, embedding sensor. This is to do some predictive health management, structural health monitoring. For the manufacturing, this sensor also will be used to automate and optimize the control. And then these sensors will also be used for disassembling, to optimize disassembling, and then see if we reuse or we completely recycle some parts of this smart fan blade. So this cognitive capability will enable us to do some virtuous cycle like that using some digital data. This can be from the hybrid twin and real data coming from the sensors, embedded sensors. So some innovative technology that we hope that we're going to validate is to have some advanced RTM manufacturing. This kind of structure are manufactured with the resin transfer model process. So we propose to embed this process with some specific sensors that will help us to two types of sensors that will be used only to optimize the process, manufacturing process, and sensors that will be used twice. We will have two targets to optimize the process and also to be embedded like the fiber brag sensors embedded in the structure for the life cycle management after. We are going also to work on some printed and electronics sensors that will be printed directly after manufacturing on the structure. Lightweight construction with all the electronic system that will be printed directly on this fan blade. And then with all of these sensors, we are going to develop a hybrid twin. So the hybrid twin, it's just going a little bit more than a digital twin by using some machine learning approach to identify the mismatch between the digital and the real data. So what we know it will be in physical and I would say numerical models, and what we don't know can be identified, can be learned from these sensors with some machine learning approach. So, and this type of hybrid twin, the idea is to work on some reduced model or that can be adapted on the fly using the data provided by the sensors. So it is some work that is that we are doing from this. We began to work on this kind of algorithm and modeling approach. So this is the data, and then to put this this reduced model in some how we say complex system simulation tools that Safran developed, that can then give us some insight on the performances of what's happened on the structures until virtual flight test. So we can put this small model in a complex one, system of system, and then see what's happened. And if in the design we optimize, and we optimize also the impact of this choice on the in-service of the structure. This will be conducted with development of some specific SHM data, probabilistic SHM data driving methodologies based on this kind of approach, because we are going to work on this fan blade in a rotary test bench to see what's happened and the effect of all these loads on it, and the fatigue test to generate some algorithm that can give some prognostic on the remaining usable life. And finally, if we see that there is some damages that are not that are severe, so then or it's the end of life of the structure. So then we are going to use some two types of recycling technology, two types of technology. Laser induced, it's what we call laser shock, laser pinning. For disassembly, the composite, the part of the titanium from the structure, because the titanium it's something that we want to keep, and then all the parts for the structure can be recycled using some Peoris technologies. So here you have the laser beam that we can generate in the layers some delaminations, controlled delamination directly. Okay, so here you have some outcomes that we hope are going to satisfy from the design, production, performance, and recovery, disassembling. We have 100% recovery of, let's say, FRP from PCM. Be back to the design, because if we have something that can be can have some functionality to track its health, so we can then, I think, be back to the design and have some damage tolerant design instead of safe flight design, which is now the case. That's all. I think just wrap up here what we want to do. Have environmentally friendly manufacturing, recycling, push industrial in the line with Europe Commission circular economy, disassembly of the hybrid material, give some new process to help the disassembly of hybrid materials. Competitive cost in the line with the concept of circular economy. Thank you. Brief.
Thank you very much, Mr. Megbald, for this insight into, I would say, Industry 4.0 technology.
Yes.
And the applications into smart structures, actually. Now, speaking about digitalization, the next showcase project, which is Dominio, sets out a number of technology enablers, including digital twin and advances in simulation that will improve manufacturing efficiency. And so also speaking about automated tape laying, automation, reversible joining, yes, etc. Now, Mr. Pablo Romero Rodriguez from the IMAN Technology Center in Spain is with us today to give an insight into the project's activities. Mr. Rodriguez is R&D program manager focused on advanced materials manufacturing for the transport sector, and an expert in the field of digitized manufacturing systems. And he is also project manager of the Dominio project. So welcome, Mr. Rodriguez, and the floor is yours.
Thank you very much. Stan, do you hear me well?
Perfect, yeah.
Okay, great. Well, thank you very much for this opportunity. It's a pleasure for us being here presenting Dominio. So, as it was commented before in the previous presentations, digitalization and MRO, for example, or manufacturing are key aspects for the next generation composites. So, Dominio tries to somehow tackles in a holistic view all the stages that happens between design and maintenance of this next generation composites by defining, let's say, a digital thread that connects all the data from the life cycle and makes it available in each stage so that every stage can be optimized. So this is the backbone of the project. And obviously we are focusing on multifunctional composites. So we will develop new sensors and obviously focusing on new manufacturing technologies, for example, tape laying and additive manufacturing of thermoplastics. So the call text was mentioning, or actually is the actual need for the transformation of the aviation sector. We need to advance in every stage, in the design, in the production, and also in the field operation, and paying a special focus on the next generation multifunctional parts. And on the other hand, we need to obviously have a very important or dedicated view to the ecological aspects, also in every stage. So this holistic view was, let's say, the backbone of Dominio, which tries to somehow, as I mentioned before, connects every stage in the life cycle and extract knowledge out of the data. So in this image, what you can see, for example, is the connection between simulation of the product, simulation of the manufacturing processes, and also in every stage you are generating data, right? So the thing here is that, okay, in the manufacturing, we are going to locate sensors in the tape laying technologies, infrared sensors or NDT for detecting the lamination or pores in defective in situ consolidation schemes. Since we are also embedding sensors within the composites, we will make use of these sensors for structural health monitoring to help shift towards the condition-based maintenance and provide valuable information based on multi-scale hybrid twins for the MRO, so that on real time the MRO can decide whether if the material can be repaired or is more feasible in terms of carbon footprint, for example, to disassemble. So all these stages, we want to connect them with the new designs, so that we can anticipate in early stages of the design what is going to happen in every stage. So this is, let's say, the concept of the project. And talking about dedicated technology, we have, let's say, three main pillars that you can see here. On the left side, you can see the materials and intelligent structures that we are going to develop. For example, we are going to work on thermoplastic for in situ consolidation. We are working on laser technologies for dedicated heat input and online control systems for in situ consolidation. We are going to develop several filaments for fused filament fabrication. One dedicated for disassembly based on magnetic nanoparticles, others dedicated for reinforcement and multifunctionality. So we are going to use continuous carbon and continuous carbon nanotube fibers for strategic reinforcement within the plies, and also for introducing sensors and heating elements for the icing, for example. And we are going to study the combination of tape laying and fused filament fabrication so that we can somehow optimize the process parameters and the sequence itself. So you can see here an image of the skins manufactured by tape laying, and on the left side you can see stiffeners made out of filaments which are already reinforced with continuous carbon fiber, as you can see here in this SEM picture. So this is on material side. On manufacturing, we are dedicating a lot of effort on online monitoring and real-time control strategies. So, for example, as I mentioned before, thermal management is key when consolidating thermoplastics for coming up with zero defect manufacturing, let's say. So we are working on laser control and also on the nozzle of the fused filament fabrication, so that the thermoplastic thermal management is, let's say, proper for guaranteeing the intimate contact and also the intimate consolidation between layers, right? And also we are going to integrate non-destructive sensors in the AFP, as I mentioned before, based on non-contact and air-coupled systems. So the idea here is, similarly, as Morpho coordinator mentioned before, to work with reduced order modeling to understand what's going on in the project, on the process, and on real time being able to adapt the heating input so that we can guarantee that defects are not occurring, let's say. So here you can see two images on the thermal management or thermal image of fused filament fabrication and the tape laying based on infrared cameras. And on the right side, you can see the third pillar, which is the digital thread, which is somehow the blood that connects all the stages. So here we have, let's say, two main developments. The first one would be design and production planning. So we are going to simulate the tape laying and the FFF process. So in advance, we know what is the better path planning, for example, to guarantee the consolidation and the dimensional stability, for example, of the components. One key aspect, of course, in digital developments are the data interoperability. So we are going to develop standard communication protocols, let's say, so that every brick or every step can communicate one to each other and extract knowledge out of it. And one of the main aspects as well in the Dominio project is, okay, we have a lot of data and we are paying a lot of attention in new manufacturing schemes, which are going to change a lot the life cycle of the sector, I would say. So it's very important that when we design new products, we design them in order to be manufacturable. So design for manufacturability is one of the, let's say, backbones of our project. So all of the data that we are going to, let's say, gather, we are going to use it in a let's say, in a feedback loop in the design phase, so that we can design components that can be manufactured. And on the other way, on the upstream, or let's say in the connection to MRO, we are also going to use the sensors, as I mentioned before, the continuous carbon nanotube fiber sensors. So we are going to couple them with multi-scale modeling. So we are going to somehow be able to interpret the implications of the signals in different scales. So we can simulate at let's say micro scale, meso scale, and larger scales the structural health of the component based out of this data. So it's not just placing the sensors there, but also coupling with a digital twin able to make the correct interpretation of the sensors. So this would be, let's say, the main development for providing value in the last part of the or stage of the life cycle of the component, which is the MRO. So yeah, 3 pillars: materials, manufacturing, online control, and the digital thread. So this picture tries to summarize our concept. It's just to give you an overview, which I think that easily explains what is going on. So we have, let's say, 3 stages in the life cycle: the product and modeling, the manufacturing, and the field operation, right? So the idea is that we are going to, let's say, store the data from engineering. We are going to store data from manufacturing out of the sensors, as I mentioned before, the quality control systems, and also the structural health monitoring data. So this is the idea, the feedback loop towards, on the one hand, self-adaptive system. So we can come up with optimized engineering schemes for proper manufacturing of the composites, and also to provide value in the multidisciplinary design optimization software, which is the main output of our project, to integrate design for manufacturability rules that will make, let's say, automated tape laying and fused filament fabrication, let's say, one of the manufacturing technologies of the future. So we are going to focus on 2 use cases, both of them integrating multifunctional aspects. We are currently defining the scope of each of them. But yeah, on the one hand, we have a leading edge with large curvatures. We are going to somehow trying to solve this curvature with the tape laying. And on the right side, an access door panel, let's say, with different requirements in terms of criticality and functionality, both of them. So yeah, finally, this is the consortium of Dominio. I would like to thank you very much, all of them, because this is a very, very challenging project, and they are actually dealing very, very well with all of the developments. So we have NTUA, Tortec, and mostly focused on materials, simulation carried out by NSAM and ESI, the multi-scale modeling by India Materials, IPC working on new developments for fused filament fabrication. EDS is working on LCA, so LCA will be integrated in the design phase. INCAS is working with the definition of requirements, use cases defined by Atsituri and BAE, providing manufacturing and composite requirements, and ESN with the dissemination and communication. So yeah, this is the main message from Dominio. Here are my contact details in case you want to reach out. Thank you very much for the opportunity once again.
Thank you, Mr. Rodriguez, for this Dominio view behind the scenes. We do understand that the digital technology is absolutely a leverage to a more sufficient or more efficient, I should say, hence less waste design and manufacturing. And I think it's also enabling a more sustainable service life through these better data analytics you presented. So thank you for the provided insights. Our next speaker is not only an experienced panel moderator, but also a coordinator of a recently started research program to turn the aviation sector to a more circular business practice, and that is the SUSTAINAir project. So Jürgen Reuter from the Austrian Institute of Technology is an expert in the field of light metal alloys, casting technologies, and sensor technologies for process monitoring. And he coordinates a project that is not only working on circular design and manufacturing, but also on the development of new recycled raw materials. So, Mr. Reuter, I'm very pleased to give you the floor and explain to us how SUSTAINAir helps to achieve a circular aviation.
Okay, thank you, Stein. Thank you very much for the introduction. So first, I will start with presentation to show you. Yeah, so you can see my presentation now. Great. Yep. Yes, perfect. Yes, okay, so I will present the SUSTAINAir project. So the third project of this MG35 call. SUSTAINAir is the abbreviation for sustainability increase of lightweight, multifunctional, and intelligent airframe and engine parts. So during the project, so I will give you first short introduction. I will show you the overall concept of the SUSTAINAir project. Then I will highlight a bit the work packages and the implementation of the project which we try to obtain. And finally, I will present also the project partners and their contribution to the project. So as you can see here on the right-hand side, the SUSTAINAir project is related to aircraft performance. The project's goal is to contribute to zero pollution and to obtain a green planet. And this is done by a circular economy approach in the field of aviation. Next slide, you can see here a short introduction regarding the project. So just here, the SUSTAINAir project addresses the major challenges of greening of aircraft, of course. We introduce a circular economy, and within the project we are 10 partners from 3 different European countries. The budget of the project is roughly 5 million euro. The duration is 24 months, and the project started very recently at the beginning of this year. In SUSTAINAir, the project partners develop solutions to increase resource efficiency and aircraft performance, to reduce waste and material costs for the total aircraft life cycle, and this beginning from the design to manufacturing, maintenance and repair, through the dismantling and recycling of aircraft parts. Here you can see a nice sketch representing the idea how to obtain impact to the circular economy. So first, from the call we have here, we picked up 4 scope items: the morphing features, the design and manufacturing of innovative joints, the manufacture and integration of novel sensors for structural health monitoring, and new MRO and recycling methods. We pick out here and develop during the project 8 key enabling technologies to end up with demonstrators which having these favorable properties. And with this all together, we want to gain key exploitable results to make impact on the circular economy approach. Here is presented the overall concept, the overall idea of the circular economy in aviation. So as Liché already pointed out during during the panel discussion, this was born at the meeting from IREA, and then the circular economy approach was then provided to the audience, and here we had in the consortium an application to gain this project for the circular economy approach in aviation. So when we are starting here with some raw materials, some first life materials, and maybe also with some remaining materials from the recycling, the so-called second life materials. Taking these materials, we start this circle of economy, we start here with the design requirements, taking into account the first and the second life scenarios. So rather new way of design. Then based on these requirements, coupons and elements for aircrafts are manufactured, applying innovative joints and joining technologies, and then damage diagnostic system for maintenance to extend the aircraft components lifetime to a maximum. Then when the end of life of the aircraft component is reached, then we obtain some automatic dismantling technologies to maximize the amount of remaining material and thus to enable a second life for it. So to result in a second life demonstrator. How this how this will look like if you break it into work packages. So here in our project, we have here 5 scientific and technological work packages. You can see here on the right-hand side, you can see here the interaction between the work packages. So we're starting here with the work package 1. The work package 1 is the circular aircraft by design. Here are the design requirements will be defined, taking into account, of course, the first and the second life scenarios. These design requirements will directly feed the following work packages. The work package 2. In the work package 2, circular manufacturing is investigated, including second life. Then the work package 3 we have here. Work package 3 is damage diagnostics work package for structural health monitoring of hybrid structural joints. And then again, we have here the work package 4 to develop joining and repair technologies for similar and dissimilar material combinations. In work package 5 here, in the work package 5, the second life demonstrator is realized with a maximum set of work package 1 to work package 4 features included. Okay, and the scientific and technological work packages I've presented here are accompanied by dissemination and communication activities, and of course also by the coordination and the management of the project. So let me switch directly now, jump into the partners and finally show the partners and their main competences to bring into the project and their main the main contributions to realize this second life demonstrator. So first I want to start with the RTDS group. RTDS group is the work package leader for the dissemination, exploitation and communication activities, and does project management assistance, Then we have the scientific and technological partners, starting with NLR. NLR, yeah, of course, they are. They focus on the research and development of composites. So as you can see here, they have some robot cell for the induction welding of thermoplasts. For the rivet removal, they have a lot of know-how. Yes, they have know-how in circular aviation and circular manufacturing, and also of the monitoring and the testing technologies we need for testing the composites. Then we have as a next partner, we have the DLR. DLR, they are specialists in making use of titanium. They're using the laser powder bed fusion process to 3D print some new structures. And also to characterize materials and to develop materials. The next partners we have here on board are uranium research. They have on the one side competences with laser welding and laser-directed energy deposition. And on the other hand, they are specialists in the synthesis of zinc oxide nanowires for sensors, nanowire sensors, and for the integration of such sensors into or onto surfaces of samples by making use of some plasma deposition. Then we have a next partner is JKU, Johannes Kepler University of Linz. So this is the Institute of Lightweight Design, which is here. So they are specialists in the damage tolerance, in the structural health monitoring, and so they are leading the work package 3 damage diagnostics. Then as a next partner, we have here the TU Delft. TU Delft, okay, we already mentioned today several times, they are specialists in aeronautical structures. So they are leading the work package 1, where we derive the design requirements. Of course, they are also specialists in the numerical damage analysis and the joining techniques. So then next we have here the company Inocon. They develop these plasma technologies together with uranium research and to try to commercialize such functional coatings and things like this. Then we have the company Invent. Invent is also working on mainly on the composite side. So they starting, of course, from aviation industry or space. They have a rather high elaborated field. They do some research and development through design and structural analysis, prototyping, assembly, and also some serious production, quality management of composite structures. And then we have another company, DTC, on board. So they are also specialists in thermoplastic composites, in molding processes, in testing, and so on. And finally, we have here the Austrian Institute of Technology, AIT. So as Stein already mentioned at the beginning, we are not specialists in composites, but we are specialists in light metals and light metal processing. So we do some advanced casting processes, we do some forming technologies, we do some component simulation, we do some material development, alloy development, and material testing, and we also can contribute with some wire arc additive manufacturing of aluminum wires. And so this is the whole consortium where we try, or where we gain to achieve the goals which we defined in the proposal, and to obtain a second life demonstrator. And thank you for your attention, and back to you, Stein. Thank you.
Yeah, thank you, Mr. Rutter, for providing us with SUSTAINAir technology enablers for more circular aviation. We do understand that a lot is still possible and has to be done every single stage in the aircraft's lifetime, which brings us seamlessly to our next important showcase, the eco-design activities within the European Clean Sky joint undertaking, where exactly for every step in this aircraft's life, greener solutions and improvements have been or are still in development. The eco-design activities in Clean Sky are led by Fraunhofer Gesellschaft in Germany. So complementing on what Ms. Sonal-Schroff from Clean Sky earlier in the panel discussion has already provided, we are very happy to welcome Mr. Thorsten Moll from Fraunhofer. Mr. Moll is Program Manager Aviation at Fraunhofer, and I am looking forward to learn more about the Clean Sky eco-design achievements, maybe also having a view on the way forward and future perspectives. So Thorsten, very welcome, and please, the floor is yours.
Yes, thank you. Stan, can you hear me?
Yeah, perfect.
Okay, yes, thank you. Ladies and gentlemen, good afternoon. My name is, as Stan said, it's Thorsten Moll, and I'm Aviation Program Manager at Fraunhofer Gesellschaft. And together with my colleague Rainer Schweppe and our team, we are coordinating the eco-design transversal activity in Clean Sky 2. Before I start, I want to thank you all for having the opportunity to present here, the SUSTAINAir team and all the audience. Thank you very much. And as we have learned, it's all about sustainable productivity in aviation, and that is what eco-design stands for. We look at it, it was mentioned also during the day, as a circular economy, and it's all about bringing the innovation steps together to make economic value and ecological value come together. And of course, this is a big socio-economic context for the entire European economy and for the entire world. What we do is we focus in the eco-design transversal activity. You will later see how it's organized on the big impact technology pathways in the Clean Sky 2 program. And we are providing a Design for Environment Guideline 2020 or 2020 plus for the European aviation industry. And what we take here is we have seen several versions of this type of illustration here. This is ours, and we employ a modern circular LCA plus model for a full life cycle analysis, closing the loop from end of life to material production. I think we have heard lots of examples already for this. And this is an important key for the sustainability and the productivity of aviation in industry. And for sure, this includes all aspects: energy, economic impact, as well as materials, processes, and resources. Basically, what we do and what is our mission in the Eco-Design Clean Sky 2 program is to optimize the whole program basically to what this forum here today stands for. And it's eco-design is a continuous investment here in sustainability. Eco-design was already implemented in Clean Sky 1. Sonal has given more insight in her presentation already earlier this afternoon. It was with a focus on airframe and systems. And I will show you on the next slide how it's implemented in the Clean Sky 2 program, which is basically, currently ongoing. And of course, eco-design will be a driver for the future program in aviation, of course. And yeah, it's a great team effort with all the parties involved, and you can imagine that's a very high level of coordination and integration activity here. This is the original program setup of Clean Sky 2, and you see in the in the center the two levels of demonstration domains. We have the vehicle domain, where it deals with fast rotorcraft, large passenger aircraft, and regional aircraft, and we have the larger system ITDs, airframe, engines, and systems. And we have implemented eco-design here as a transversal activity across all of these strategic platforms, and to be connected to all of the demonstrators which are developed and implemented in these platforms. So this is what we have. We have a wide and cross lying transversal activity here in the Clean Sky 2 program. And I will give you some example here on the next slide. This is an overview. Basically, the slide comes from Clean Sky 1. So we are exploiting Clean Sky 1. Of course, it's not individual modules here. It's a continuous activity. And with Clean Sky 1, we started this framework of the picture basically is it's an outcome of the Clean Sky 1, but it's complemented by some examples of the Clean Sky 2 domain. So we see structural parts, of course, of the airframe. We see interior parts, as was mentioned already before. We see the biomaterials. We see connectors and electronics. And we see metallic part. We see composite part. And we see already engines in there. And also some technologies which are quite little here with gaps, what also was mentioned already before. And so we are, in the moment, we are bringing it to particular demonstrations in Clean Sky 2. We have defined some flagship demonstrators, which are the ones where we will derive the eco statements to. And I have brought